So this is the MTH312 midterm 2 question 1. And so it says solve the system of differential equation by systematic elimination, d-operator method, and solve for x of t. So this is the MTH312 midterm 2 for the fall semester of 2024. And question 1 is asking, solve the system of differential equations by systematic elimination, d-operator method, and solve for x of t. This question is worth 12 points, and you can expect to get something very similar if you are taking the course. So let's get right into solving this. So the first thing we want to do is, let's write it out. Let's write our equations. So we have x prime is equal to 3y plus t squared, and we can rewrite this as x prime minus 3y is equal to t squared. Now as for this equation right here, let's also rewrite that, and we can just rearrange that as negative 2x prime plus y prime, and it's equal to e to the power of t, as so. So there we have our two equations now. And what we want to do is we want to change it to the d-operator method like they are specifying. So essentially, an x prime would technically mean we have dx. So dx minus 3y equal to t squared. We've changed our first equation into the d-operator way, I guess you could say. Alright, so now we have negative 2 x prime, so negative 2 dx plus y prime, so this is going to be dy, and it's equal to e to the power of t. So now we have both of our equations as such. So let's copy this down now. Now what we want to do is we want to do a systematic elimination such that we are only left with x's in the equation, allowing us to solve for x of t. So what can we do here? Well, we can multiply certain things to eliminate, because that's what you're supposed to do. So we want to get rid of the y's, right? So here we have a plus dy, and here we have a negative 3y in this equation right here. So what we can do is we can multiply this by d. We can multiply the first equation by d, because once we do, this will give us d squared x minus 3dy. Now if we have 3dy in our second equation, we can multiply a negative 3. Now if we go ahead and do as the following, so this will give us what? D squared x minus 3dy, which is equal to d t squared. And then we will have negative 2 times negative 3, that's positive 6. Positive 6 dx, and then we will have minus, we want to multiply it by just a positive 3. There's no need for a negative. Plus 3dy, it's equal to 3et. Now you can see that we have a negative 3dy and a plus 3dy. So when we actually add these equations, these are going to cancel out, and we will see that. So let's say we want to add these, right? Let's add these equations, and we'll see we get d squared x minus 3 dy minus 6dx plus 3 dy is equal to dt squared plus 3 et. Now we can see the minus 3 dy, the plus 3 dy, this cancels out, leaving us with only x's. And this is perfect because we have to solve for x of t. So let's rewrite our equation now. We have d squared x minus 6 dx, and it's equal to dt squared. Well, what is dt squared? Well, if we think about it, d is going to be dt, so we have to differentiate it with respect to t. So if we differentiate t squared, that would be 2. That would be 2t. And so our dt squared is essentially 2t. And then we have plus 3et. So this is our equation. Now we basically have one differential equation. So what we can do is we can just solve this differential equation regularly now. So if we think about it, d squared x, we can convert this back into the regular method. We don't need the d operators anymore. You can keep them, but we can just think of this as d squared x is just x double prime, and minus 6 dx, which is just minus 6x prime, and that is equal to 2t plus 3et. Now we can solve for our xc, our complementary solution for x. So if we have x prime minus 6x prime, that is technically m squared minus 6m, and it's set to equal to 0. So then we can obviously factor that m out, leaving us with m minus 6 is equal to 0, and we get m1 is equal to 0, and m2 is equal to 6. So that means our complementary solution, xc, is going to be equal to c1 e to the power of 0, which we know e to the power of 0 is just 1, plus c2 e to the power of 6t. So this right here is our complementary solution. Now we need to find our xp. And so we have to use a guess function initially to start off. Well, what are we even basing off our guess function off of? We're basing it off of this. And let's just call this function g of t. So we need to guess, or we need to base off our guess function off of g of t. So we can see that in g of t, we have 2t. For our guess function, we can use, so let's write x of p, and that is equal to at plus b. And then we have 3et, which for our guess function, we can just do cet. And there you go. This is our guess function, or this is our initial guess function. Now we have to make sure and check that our complementary and our xp do not have any sort of same terms. And from what it seems like right now, it appears that there is a same term, and that same term being the b and the c1. These are essentially the same thing. It's just a constant by itself. So what we have to do is we have to multiply this at plus b by a t to give us at t squared plus bt plus cet. And now this is our actual xp. So what we have to do now is we have to set this equal to the g of t. So let's set that equal to each other. There. Now we have to group, or well, my mistake. We don't just set these equal to each other, we basically have to put our x of p into the original differential equation. So let's take our equation here, let's paste it, this. So we have to actually first differentiate xp because we don't know what x prime is, which is just that. And we also don't know what this is. So we have to find the derivative of xp twice. So then, let's go ahead and do that. Let's write our xp once again. Let's differentiate it once. So we would have 2at plus b plus cet, and let's differentiate it once again, double prime, and so 2at derivative of that is just 2a plus cet. So now that we've differentiated it twice, we can plug these back into our original differential equation. However, let me just add another page. Okay, so I've just added another page. Let's take all of this information. Okay, so let's now plug it in. So we have x prime minus 6 x prime. So we have double prime minus 6x prime. And this is equal to 2t plus 3et. So let's go ahead and distribute that 6. So we would have 2a plus cet minus 6, or well, 6 times 2, so minus 12at minus 6b minus 6cet, and it's equal to 2t plus 3et. And now what we have to do is we need to solve for our undetermined coefficients, our a, c, and our b. That's what we need to solve for. So there are a couple of ways to do this, or well, mainly two. What we're going to do is actually group them up and then solve. So basically, let's group up all the functions with t first. So for example, we know that we'll have negative 12a, and that's pretty much it for t. And then let's group up the e to the power of t functions, so c, and we have negative 6c as well, 6c, and that's pretty much it. And then let's write the rest of our functions. So we would have plus 2a minus 6b, we can put these in brackets. These are like constants. Okay, that should be all of them. And then we can write, of course, equal to 2t plus 3 e to the power of t. Now we can set them equal to each other, the corresponding functions. So for example, we have 2t. Well, we can set that equal to whatever is in this bracket. So negative 12a. Okay, let's write for t. Negative 12a is equal to 2t, or well, just 2. And then we can solve for a. A is going to be equal to 2 divided by, or no, sorry, 2 multiplied, tweaking out this, and we know that this can simplify to give us negative 1 over 6. So that's our constant a. Now the second constant we can find, which is really easy, is c. So we can use the e of t function. Okay, so c minus 6c. Well, we know that c minus 6c, this is just c, it's going to be negative 5c, and that is equal to 3et. So it's equal to 3. So all we have to do now is isolate for c, and we get that it's equal to negative 3 over 5. Now all we have to do is just find our b. So for our constants, let's just say k for constants, we have 2a minus 6b, and it's equal to, well, there's technically a constant here, and it would just be a plus 0, so we can set it equal to 0. Now we know what a is, so we can actually plug that in. Let's go ahead and actually solve first. So we would have 6b is equal to 2a, and then we would have b is equal to 1 over 6 2a. Now, what is a? Well, we know that a is negative 1 over 6. Just like so. And then 2 times negative 1 over 6 would give us 1 over 6 times negative 2 over 6, and then negative 1 over 6 times negative 2 over 6 would give us negative 2 over 18. Oh wait, there is something wrong here. I should be 1 over 3. Well, technically it would be 2 over 6, which simplifies to 1 over 3. And this would give us, this would not be 2, would it? It would just be 1 over 3. A. So let's redo this whole part. So this would give us b is equal to 2 over 6a, which is equal to 1 over 3a. 1 over 3 times negative 1 over 6. This simply gives us 1 over 18. Okay, there you go. So now we have found all of our constants. We found b, we found c, and we also found our a. So now we have determined the coefficients. We can basically rewrite our xp now. So xp If we recall, our xb was at squared plus bt plus cet. So our a is now negative 1 over 6 t squared minus 1 over 18 t, and this is minus 3 over 5 e t. So this is our xb. Now we know to find x of t, we have one final step. And to find x of t, all we have to do is add xc plus xp. So that means our x of t is going to be equal to our xc, so c1 plus c2 e6t, and then plus our xp. And this would be the solution to this question number 1. So this would be xt.